The function r of t equals 60t minus 2t squared represents the value of an ounce of palladium in the United States dollars as a function of the time t in days. Find the average rate of change of r of t over the time interval t, t plus h, where t equals 5 and h equals 1, 0.1, 0.01 days. Estimate the instantaneous rate of change of r with respect to t, specifying the units of measurement. We were given that t equals 5 and there are 3 values for h, and so we will need to compute 3 average rates of change. The first one is over the interval t 5, t 5 plus h, where h is 1. And so this is the interval 5, 6. This is for h equals 1 case. The average rate of change is given by the formula f of b minus f of a over b minus a. In this case, a is 5 and b is 6. And so the average over the interval 5, 6 is r of 6 minus r of 5 over 6 minus 5. The function is now r of t instead of f of x. R of 6 is 6t, and then t is now 6 minus 2, and then t is now 6. We replace or substitute t with 6. Minus, this is only r of 6. We still need to minus r of 5. R of 5 had 2 terms as we expect, and so we're going to put this in the bracket. R of 5 is 60 times 5 minus 2 times 5 squared. And again, we simply replace t with 5 to obtain r of 5. Over 6 minus 5 is 1. Once we show our work like this, we can then use a calculator to compute this. The numerator is negative 22 and the denominator is 1, so this is minus 22. The unit in this case is the units of the numerator, which is dollars, and the unit of the denominator is day. T represent days and R represent the dollars amount. For h equals 0.1, the interval is 5, 5 plus 0.1 is 5.1. We simply write 5, 5.1 knowing that the increment is 0.1 instead of writing these down. And so the average rate of change over 5, 5.1 interval is now r of 5.1 minus r of 5 over 5.1 minus 5. And we do the same thing. The function is 60t minus 2t squared, so 60 times 5.1 minus 2 times 5.1 squared minus 60 times 5 minus 2 times 5 squared. The denominator is 5.1 minus 5, which is now 0.1. Again, once we set it up, we can simply use a calculator to evaluate or compute this expression. In the numerator, we obtained negative 2.02, and the denominator is 0.1. And so this will give a negative 20.2, and the unit is dollars per day. Lastly, for the average rate of change, when h equals 0.01, the interval we will work with will be 5, 5.01. And so the average over the interval 5, 5.01 is now r of 5.01 minus r of 5 over 5.01 minus 5. And again, before we use a calculator, we should write this down first. Write the expression that we need to put into a calculator, which is 60 times 5.01 minus 2 times 5.01 squared. We plugged in or substitute 5.01 into this given function r of t. 60 t minus 2t squared, where t is 5.01, minus, we still have r of 5, but r of 5 is 60 times 5 minus 2 times 5 squared. Inside the bracket, the denominator is now 0.01. We can now use a calculator. If we put it in a calculator, we will get negative 0.2002 for the numerator. And in the denominator, we have 0.01. This is negative 20.02, and the unit will be dollars per day still. We were given 3 H values, and we computed 3 average rates. We also see that these intervals, we computed, the intervals are getting smaller and smaller as H go to 0. As is in this case, we obtain the instantaneous rate of change. We see that these rates of change, negative 22, negative 20.2, negative 20.02, they're approaching a number here, and that number is negative 20. And so we would say that the instantaneous rate of change is negative 20, and the unit for this rate is still the same as the average rate of change, which is dollars per day.